70 million years ago, in the dense, shaded undergrowth of the ancient Gobi Desert, 5 tons of muscle pushes through the ferns. Extending from the hands of this massive animal are 3 curved, gleaming claws. Covered in a thick sheath of hard keratin, each blade measures up to a full meter long. Hold your arms out and picture your fingernails stretching the length of a samurai sword. These are the absolute largest claws in the entire history of life on Earth. You might expect a killing machine built around those weapons. Instead, the rest of Therizinosaurus looks entirely out of place. It has a long, graceful neck, a comically small head, and a genuinely round, bulging gut. Inside that tiny skull, there are no serrated teeth for tearing meat. It has small leaf-shaped teeth, suited strictly for chewing plants. The animal wearing the hands of a horror movie villain was entirely vegetarian. Every calorie an animal consumes is an investment. Growing and maintaining a meter of solid bone and keratin is an enormous biological expense, a heavy price to pay for a creature that spends its life picking salad. To understand why it grew them, we can look at a 2023 study led by Zichuan Qin at the University of Bristol. They stopped guessing about the dinosaur's behavior and started measuring its anatomy. The researchers took CT scans of the fossilized bones and built 3-dimensional digital models. Then they ran those models through the precise engineering software used to test whether an airplane wing will hold under pressure. This schematic outlines the mechanical problem with the claw's structure. As a physical tool, its geometry is poorly suited for combat. It is stretched incredibly long, but it remains exceptionally thin and narrow. A short, thick claw acts like a crowbar, but stretch that material out to a meter without adding bulk, and you create a brittle blade. When the software applied the twisting, sideways stress an animal experiences in a real physical struggle, the narrow claw concentrated the force in all the wrong places. A hard impact against an attacker would likely cause the bone to twist and bend. The results were definitive. The researchers concluded that under combat conditions, these enormous claws were useless in mechanical function. The study reveals a rare instance of nature prioritizing appearance over utility. The largest claws in the fossil record were simply not built to survive the impact of a fight. To trace how Therizinosaurus ended up this way, we have to look back at its ancestors. It is a theropod. It comes from the exact same family tree of apex hunters that produced Tyrannosaurus rex and the raptors, but somewhere deep in that lineage, a group of these carnivores stopped hunting. We can see the shift in a transitional fossil from Utah called Falcarius, which shows a lean predator slowly adapting to chew vegetation. Digesting raw, prehistoric leaves is difficult. The body needs a massive internal fermentation tank to break down the tough plant matter. Over millions of years, the sleek, running frame of a hunter expanded outward into a slow, top-heavy shape to accommodate a giant gut. We can see the flexibility of this evolution by looking at their closest cousins, the alvarezsaurs. They started from the exact same predatory ancestors, but solved their environmental problems with a radically different approach. While Therizinosaurus expanded to 5 tons and grew delicate, meter-long sickle arms, the alvarezsaurs shrank to the size of chickens. They developed short, heavily muscled arms, ending in tiny, ultra-tough claws, engineered to punch through the hard walls of termite mounds. Nature took one ancestral starting point, the hands of a hunter, and pushed it in 2 directions. One cousin shrank to dig for insects, while the other grew into a giant that prioritized display over durability. Those massive hooks did serve one practical purpose. Combined with its long arms and graceful neck, the claws allowed the animal to reach the highest canopy, accessing leafy branches far above the heads of other plant eaters. Modern anteaters use a very similar technique. Rather than slashing, the Therizinosaurus likely used its claws as specialized gardening tools, gently hooking high vegetation and dragging it down towards its mouth. But reaching for leaves does not fully explain the extreme, fragile length of the bone. The Bristol team determined the claws were heavily driven by sexual selection. Much like a peacock carrying a massive, heavy tail that offers no combat advantage, These claws served as a biological billboard. They were an advertisement of health. A Therizinosaurus could simply rise up, spread its arms wide, and wave those enormous, gleaming claws in the air to intimidate a rival or impress a mate. Two males squaring off at a watering hole never needed to strike each other. The size of the display decided the victor. They won dominance without ever risking a scratch. This 5-ton giant roamed the Cretaceous, using the hands of a predator to prune trees and signal rivals. It suggests that even in a world of apex hunters, a high-stakes performance can be just as effective as a lethal strike.